This is our Wednesday and Thursday lesson, graphing tangents. And you're like, but Miss Chang, I barely know how to graph sine and cosine. So just continue with the homework. Make sure you help each other, please. Okay, but we're going to go through this. You'll find that tangent is actually easier than graphing sine and cosine, all right? So you guys, please find this page on your notes. How do you graph the other trig function? I know you've been looking for this, tangent, okay? Part 1, the unit circle and the tangent function. Now let's warm up and fill in the unit circle at each of the indicated angle measures. Go! Come on, guys. Oh yeah, we're going to fill it out with the sine and cosine values, and we're pros at this now, right? Okay. All right. Sorry, I didn't see it, okay? Are you guys getting these? All right? Yes. All right. So why I made you guys do this, you'll understand later. And again, hint, tangent is sine over cosine. Okay, y over x. Okay. All right. So we know all this pretty well. Now let's go back here now. Find the tangent of each of the following angle measurements. So you guys, a tangent of negative pi over 2 is over here, and it's going to be sine over cosine. It's going to be defined. Okay. So why don't you guys go ahead and fill in this? Stop the video, fill in everything, and then look up when you're ready. Hey, who hasn't shut this down yet? I know some of you guys are like ignoring what I'm telling you to do, okay? Anywho, all right? And you guys, look, I want you guys to recognize something here and here. Okay, negative pi over 2 and pi over 2 is undefined. Okay, I wonder what kind of significance that has, okay? All right, now let's plot these tangent values, all right? Just like sine and cosine, these have values, right? Okay, so I'm going to put a 1 here and a negative 1 here. And I'm going to label these guys just like this. You guys, we're going to graph this way. Our angle and then a tangent of theta here. Okay, our tangent theta. And this guy's going to be pi over 4, pi over 2. We're going to grow in pi over 4. So 3 pi over 4. It's going to be pi. 5 pi over 4, 6 pi over 4, 6 pi over 4. And you guys will see that I always just keep the denominator the way it is. So it's 6 pi over 4, and I know it's rounded to 3 pi over 2, reduced to, okay? 7 pi over 4, 8 pi over 4. And you can reduce them however you like. I just like to keep it that way because it's easier for you guys to see what's happening, okay? All right, so you guys, now let's do this, okay? It's undefined where? Negative pi over 2, undefined. That means there's an asymptote there. Okay, there's an asymptote there back, okay? And pi over 2, there's also an asymptote there because it's undefined. That means it can't equal that, okay? All right, now let's do this. At pi over 4, it's negative pi over 4, it's negative 1, so I'm going to go down negative 1. 0, it's 0. At pi over 4, it's 1. And you guys, those are the 5 points. 1, 2 asymptotes, and then 3 points between is all I need for you guys for tangent graph. In the graph, the general format is going to be this. It's going to reach the top of the asymptote. Okay, it's going to go towards the asymptote, but it's never going to reach that. So it's going to go something like this. Okay, just put the arrows to indicate that. And you guys, now, you guys see how negative pi over 2 to pi over 2, what's the distance between that? It's pi, right? Because remember, tangents, period is pi, okay? So you guys, add another pi to pi over 2. What do you get? 3 pi over 2, which is here, and that's another asymptote. And you always have the center, and you always have your little max, not max and min, but these other 2 critical points. So here we go. So tangents always look like this, and you know that it's going to go like this. And I just need you to draw that little, I'm going to call these guys legs, okay? So I need you guys to always finish it off by drawing other legs next to it. If I say 2 periods, these would be the 2 periods. Okay? And of course, you have to label the critical points here. This will be negative pi over 4 and negative 1. This will be 0, 0. This will be pi over 4, positive 1, and your asymptotes there. And asymptotes you'll always write for me separately anyways. Okay, we're ready. Let's try this, okay? Part 2. Go to the next page. Part 2, it looks like this. And this is exactly what we graphed, huh? Okay? Period is going to be pi, right? And the center, there's always a center, and the 2 other points is all I'm going to need from you. 2 other points, here and here. And you guys think about it. Isn't pi over 4 and pi over 4, doesn't it always give you 1? Because the sine and cosine values are equal, right? So either gives you 1 or negative 1, depending on what quadrant. So why don't you guys stop the video really quick and finish this part here, if you can. Actually, you know what? Let's actually answer these questions together based on what you see. It says here, based on the graph, complete the following. Okay? F of x equals tangent of x has vertical asymptotes at where? Well, where do you start? I don't care what you guys write, but let's start from negative pi over 2. You're right, negative pi over 2, also pi over 2, also 3 pi over 2, right? And also 5 pi over 2, etc. So look at this, you guys. How can you represent that? Okay? Think about that. It's every pi, right? So we write this like the following. X is equal to pi over 2, because that's our first value, right? Plus k pi. K is any real number, any integer value, okay? So we're going to add a pi to every however many k's you want, and that's going to give us the actual asymptotes. In vertical asymptotes, we always write it like this, right? Because it's a vertical line, okay? Number 2, f of x equals tangent of x has x-intercepts at where? X-intercepts? Aren't these x-intercepts? So we start, and aren't these x-intercepts? Aren't these x-intercepts? That means it's negative 2 pi, based on what you see, pi, negative pi, 0, pi, 2 pi, and so forth, okay? Okay? And that makes sense. What's tangent of 0? What's tangent of 0? What's tangent of 0? Is 0. What's tangent of pi? Right? It's going to be 0 over 1, which is 0. Okay? 0 over negative 1. The domain of f of x equals tangent of x is what? You guys, what are the possible zeros? We're going to come back to this guy right here. I mean, domain. We're going to come back to that guy. The range of f of x tangent of x is what? What's the range, you guys? Think about it. It goes on indefinitely forever, right? So it's going to be all real numbers here. Okay? All real numbers. And now about the period, we talked about this, is pi. This is the trickiest one. Think about it. Domain. What can't x be? Okay, what can't x be? Think about that, okay? So, it's all reals, right? All reals, except what? So I'm going to write this. It's not going to make much sense at the beginning, okay? Except odd integer multiples of pi over 2. So I want you to think about that, okay? I want you to think about that, okay? So you guys, we have pi over 2, right? And how about if I multiply it by, if I multiply k is an odd integer, right? So you guys, you know what? I'll explain this in a sec after we go through a few, okay? So think about it, odd integer multiples of pi over 2. Okay? So pi over 2, and it can't be 3 pi over 2. So it's every value that's an odd multiple of this guy here. Okay, let's see if it'll make more sense after we start graphing. All right, part 3, the general form of the tangent. Not much different than what you're used to. You're right, it's much simpler than actually the sine and cosine, huh? Okay, so let's actually go through this. After part 3, I'm going to stop the video and make a part 2, okay? All right, so you guys, same kind of thing. You have your A, B, and C. And of course, you can also write this as A tan B, x minus C over B, okay? Same sort of thing. A is amplitude, vertical stretch, or a shrink. It doesn't indicate height or anything, okay? For example, here, our A was 1. That's why we went up 1 here, okay? B, number of cycles, as always, okay? Number of cycles. It's going to tell us how many cycles in a period, which is a pi, right? Equation for asymptote, we're going to come back to, but let's talk about period. Period is going to be pi over B. Or we could say that means B is equal to pi over, period over pi. Sorry, let's erase that. What's B going to be then? B is equal to pi over period. Okay? All right, same kind of thing. This comes from that, right? Because we're going to multiply B, and then we divide by period. Okay? So, understand that? All right, now equation for asymptote is probably the most difficult to comprehend, but it's going to be quite simple for us, okay? So think about this, you guys. Don't the asymptotes happen at pi over 2 and negative pi over 2? So, if there was a phase shift here, that means it would move the same amount. So there's two ways to write this. Bx minus c, okay, which comes from that form, phase shift, is equal to plus or negative pi over 2. Another way to think about it, or same with the other guys, right sine and cosine, we do it the same kind of way. Or we could do x minus c over b, which is a simplified version after the b's been factored out, is equal to plus or negative your period over 2. Your period, the period of this particular tangent function, okay, over 2. So however you want. So that means x is going to equal c over b plus or negative your period over 2. Okay? But then you guys, if you simplify this, you actually end up getting this. All right? So let's see what else I can mention. Just write that for now, and we'll graph some, okay? Let's see what else. So amplitude really is irrelevant of a tangent, right? Irrelevant. Okay? It doesn't really have like a height or anything. It just tells you from your, you know how you have your asymptotes, and you have your 0, and you have your 2 points? It just tells you that guy right there. Okay? That's the amplitude. Let's see. Tangent is also an odd function. Okay? But I think we talked about that briefly in the past. Okay. Okay. Let's do this. Let's graph. All right?